Hi everyone. So today we'll be doing Leetcode question number 1557, that is minimum number of vertices to reach all nodes. So let's see what the question is about. So in the question we are given a directed acyclic graph. So we know that there are no cycles in the graph and it has n vertices numbered from 0 to n minus 1, and we are given input in the form of array of edges. So you can see in this example that there is an array of edges in which 0 comma 1 denotes that there is an edge from 0 to 1, and similarly 0 comma 2 denotes there is an edge from 0 to 2. So like this, it's a directed graph that has been constructed by these edges. So what do we have to do is that we have to find the smallest set of vertices from which all nodes in the graph are reachable. So basically it's like that you will always have a solution that will be unique every time, and you need to find certain set of vertices. If we combine them together, then we are able to reach every node in this graph. The thing is that only from one node, it is not necessary that we are able to reach all the nodes in the graph. So that is why we are asked the smallest set. So the set can have one element, two elements, three elements, or maybe more than that, given the required size of the graph. So let's see how to solve this question. So this is the example that I've taken over here. So in this thing, you can see clearly that if we say that there is an edge u to v, right? So this means that v is always reachable from u, right? So we can surely say that the node v will always be reachable by at least one node, that will be u, right? So this means that v will not be in our answer set, because v can be reached by some other node, right? So v cannot be the starting point. So we need to find the starting point which has basically an n degree 0. By n degree 0, I mean that if there is an edge from u to v, right, and u has no incoming edge, it only has outgoing edges. So that means that u has n degree 0 and it can be used to reach all other vertices. So in this example, we can see that 0 over here, 0 to 1 is edge. That means that 1 is reachable by 0, right? So since we have to find the smallest set, if we were given to find the largest set, then all of them can be included. But we need to find the minimal possible set, like it should contain the smallest number of vertices. So that is why we need to see that the node with n degree 0, that means that it cannot be reached by some other node. So definitely that has to be in our answer set, because we need to start from that node, because it cannot be reached by some other node, right? So all the nodes basically which have n degree 0 have to be in our answer set, because we need to start a traversal to them once to reach all the nodes, right? So in this case, the nodes with n degree 0 are the 0th node and the third node, right? All other nodes are reachable by some other node. So to do this, we'll follow a very simple algorithm. We can create a map in which we are just going to mark. As I said, that if there is an edge from u to v, then what we are going to store in the map is that if there is an edge from u to v, then that means that v is reachable from some node, right? So we are going to mark v as true. That will denote that v is reachable. So that cannot be included in our answer set, because it can not be a starting point. The starting point can only be the node which has n degree as 0. So let's do a traversal as a dry run so that you can understand it well. So so when we start through looping through this edges array, we encounter 0 1. So that means there is an edge from 0 to 1, right? So we see that like first of all, this map that has been initialized here, it takes integer and boolean values to make it true or false, right? So every time we see a u to v edge, so we will see that the v over here, that is 1, was it present in the map or not? So if it was not present in the maps, basically what we are going to do is that we are going to make it as true, because if there is an edge from u to v, we will always be reachable from some u, right? So we are going to mark it as true. Now when we loop to the second element, we see v is 2 here. So we'll mark it 2 also as true. That means 2 is also reachable from some vertex. So that means it doesn't has in degree as 0. So then we encounter 5 and then we mark 5 as true. Then we come to 4 and we mark 4 as true. And then we again have 2 here. This 2. So we already had that in map, so it's already marked true, so we can ignore that. It won't make a difference, right? So now we have our map which contains the values which are reachable by some other node, right? So they can never have in degree 0. So they are always reachable by some another node. So they cannot be included in our minimal set that we have to return as answer. So now this looping is done. So we loop through the edges array one more time and we will see again after this map has been constructed, we'll see that like suppose we are on first element, we check for the first element in every indexes array, right? So we look for every u here. So we check that is the 0. So we'll check that can this first element of every index be included or not in our answer array. So we check 0. When we check 0, we see that 0 is not present in the map. That means that it cannot be reached by some other vertex. So it has to be a starting point and it has to have in degree as 0, right? So we will include it in our answer. So our answer has 0 now. So now we traverse to the second element and see. Again we have 0 here, right? So we'll again check and see that 0 is not present. So what will happen is we will again include 0 in our answer. So we don't have to include it duplicately. So to avoid those duplicates, if we see that 0 is not present once, so what we'll do is we'll make it as true so that we don't encounter 0 again and put it in our answer, right? So the next time you will see 0 is, you will see that it has already been either reachable by some other node or it has already been present in our answer. So we'll ignore this 0. Then we come to 2 and we see that 2 is present in the map. That means it is reachable by some other node, so we will ignore it. Then we come to 3 and see it's not in our map. Then that means that it has to have in degree 0 and it is not reachable by any other node. So we have to mark it as 3 because it has to be a starting point. Then we come to 4 and we again see that 4 is present. So, oh yeah, when we mark 3, so we also have to make it true so that if any other 3 to some other vertex edge was present, so we don't include that duplicately, right? So then we come to 4, we see that 4 was already present, so we have to ignore it. That's the end of this edges vector and we have our answer, that is 0, 3. So basically these are the vertices which have in degree 0 and we have to start our traversal from them. So if we want to reach all vertices, so this is a minimal set that we can form. So I hope that's understandable. And if we talk about the time complexity will be O of E. So E is basically the length of the this vector, edges vector we have. So it is O of E, and space complexity is linear. That will be O of we can say like whatever number of elements are in the map, because we are using a map, so it has to be O of n. N is the number of elements in the map at the last stage. Now let's code the solution up. So the code is going to be very short and easy. First we create an unordered map and of int bool and we name it as visited. Then we have to create a vector which stores our answer. So we are going to loop into the edges vector, and as I said, for every edge u to v, we are going to mark the v over there in that u to v as true, because it will always be reachable by some u, right? So edges of I of 1 has to be made true. And then our first loop is done, and so I'll copy the same thing. We have to loop over it again. Now to check that in our u to v edge, for every u that we have, is this u reachable by some other node or not, right? So we'll check that if visited of edges of I of 0 is false. So the reason I wrote false here is because if it's not present in the map, then by default the value returned will be false, because we have taken bool here. So the default value of any value that we specify in the map will be false. So this means that it is not present. So what we are going to do is we are going to push it back into our answer, and then we are also going to make it we are also going to make it true, so that we don't duplicate our answer again. So that's it, and in the end we return our answer. Let's see by running it. You can see it has passed. Now let's try submitting it. So yeah, here we are done with this solution. I hope you guys liked and understood by the video. Thank you.